Now, I've already mentioned this once, but let me remind you that anytime I use an expression which is of one type but is expected to be used for a different type, for example, the function doStuff over here expects two integer arguments. But what if I pass into it an expression which doesn't evaluate to integer, but it evaluates to something else, like char? Let's imagine that this function over here, char function, returns a character, not a integer. Or what if I use a function which evaluates as float? Or what if I try to assign a character to a variable which I declared will be integer? Or what if I try to give a floating point number to a variable of type integer? So I already explained this once, but I'll go over it again. Usually this should be invalid because I'm trying to put one type into a different type, and C++ has very strict rules about types of variables. Still, the C++ compiler will still try to use that expression as the expected type. So when I pass a character into a function that awaits an integer, it will still try to use that character as an integer, if it's possible. How do we know if it's possible? Well, with the C++ built-in types like integer and char and float, most of the time it will be possible to put one type inside of a different type, like over here putting a character inside of integer. And that's because ultimately all of the built-in types, and in some weird cases even Boolean, are all number types. They all hold numbers. Integers, of course, hold numbers, that's for sure. The funny thing is that character variables also hold numbers. The only thing is that with character variables, the number that they hold is converted into a letter out of a certain chart, a code page, which has the exact specification of which number means which letter. But ultimately, the char variable holds numbers. The float variable also, of course, holds numbers. The only thing is that if you try to put a floating point number inside of an integer, only the whole part of the number will be put inside and not the fractional part. But usually it's a bad idea to do this kind of conversion, which actually is called casting in C++. Like right over here, I'm trying to cast a floating point value inside of an integer variable, and over here I'm trying to cast a char into an int, and over here as well I'm trying to cast a char into a int argument, and over here I'm trying to cast a float into a int argument. So even though it works, but most of the time it's a bad idea, and you should have your types clarified. Now this is all pretty simple with built-in types like integer and char. When it comes to user-defined classes, like the class soldier over here, then casting becomes a more complicated issue if you try to cast from one type into the soldier type, just like you try to cast from char into integer. This is more complicated obviously because it's no more a simple built-in number type. This is a more complicated type which you yourself created, and the compiler only knows how to cast different types of which the compiler knows about, like the built-in C++ basic types. But the compiler doesn't know how to cast around from your type to a different type, or from a different type to your type. We're going to learn about casting in future videos when we learn about C++ casting and operator overloading. For now, just remember that you can, but you shouldn't, cast from one basic type to another basic type, like casting from char to int or from int to char, keeping in mind the rules of integer wrapping as I explained in a previous video. Another thing I wanted to clarify is about name clashes in C++. Unlike in the English language, in which one word can have many different interpretations, In C++, every word, or as it's called, identifier, has pretty much only one single meaning. The word int, of course, means the creation of an integer variable. It cannot mean anything else. Well, actually, it doesn't mean just the creation of an integer variable. It can mean also a few other things, as we'll see later on, but it basically refers to the basic C++ type of integer. I can't have a variable name called integer. Right now I'm going to try to create an integer variable called int and give it the number 6. I'm going to get a compiler error that we don't know what's going on over here, because the identifier int is already reserved by C++ as the type, and I can't use it as a variable name. The same thing as if I created a variable called x, then the identifier x is already reserved, and I can't create a different variable of type integer, of type float, or any other type which will have the same identifier name x, because that name x is already reserved. Likewise, the identifier cout is already reserved by the standard cout object, which we included with IOStream and using namespace std, so I can't create some other variable, some other object which is called cout. The truth is, if I wouldn't include IOStream and I wouldn't be using namespace std, I would be able to create a variable called cout, because at that point this cout object wouldn't exist, so the identifier cout would not be reserved. But now that we did include it, and we are trying to use it, then the identifier cout is already reserved and we can't use it for something else. The same rule will apply when you're creating classes. I can't create two classes which are both called soldier, because once I declare the class called soldier, that identifier is already reserved. I can create a different class called soldier1 or soldier2, but the identifier soldier is already reserved. Now, this rule about name clashing has its limits. For example, even though I created a integer x in my main function, I can still go ahead and create a different integer x in a different function, and we won't have any name clashes between this function and that function. And that, of course, is because of the rules of scope, as we learned in a different video. The rules of scope will separate between one bunch of identifiers and a different bunch of identifiers, so that you can have the same identifier in the different functions. Another limit to this rule, for example, is in my soldier class I created a method, a function called attack. So the attack identifier is already reserved, but only inside of the class soldier. So I can go ahead, no problem, and create a different function called attack, which does not belong to the soldier class, and that won't be a name clash, because this one belongs to the soldier class and this one doesn't. Same thing as if I create a different class called stuff or whatever, I can also have its own attack function, because this one belongs to the stuff class and this one belongs to the soldier class. And this is all, of course, because these unique identifiers belong to different worlds, to different levels of scope. This attack belongs to the soldier scope. Any other attack functions will probably belong to different scopes, just like integer x over here and integer x here belong to different function scopes. The only problem will begin when you have two identifiers with the same name which will exist inside of the very same scope. Like if I try to have two different integer x's in the same function, or if I try to declare or define two functions with the same name which are both in the same scope right over here. They don't belong to any classes, they're just plain old functions out in the open, and they both have the same name, the same return type, and the same amount of variables which are going to be passed into the function. You can have two functions with the same name if they differ in the return type and in the types and amounts of variables that they pass. We're going to learn more about this in function overloading in a future video.